Hello everyone, let us start the class. So in last class we have seen how to find out the decision boundary between two classes when their sigma is different, that is covariance matrix is different. We have not seen till now how to compute this, so I will tell you today how to do this, and I hope you have got this vertex point for your problem using the equation that was given to you earlier. Okay, so this equation was given to you and this is your decision boundary, and use this ABC to find out the vertex. So vertex is here in this case, and you can confirm this by using your own calculation. Now today we will see with the problem how to find out covariance matrix for given data. Now, before I do that, let us briefly revise what is covariance. So, covariance is a measure of the relation between two random variables and to what extent they change together. Okay, say there are two variables A and B, they behave randomly. So, what is the dependency of A on B or B on A? So, this will be told to you by covariance matrix. Say A is increasing and B is increasing, so there is a relation, or A is increasing then B is decreasing, then there is inverse relation, or vice versa. So that is defined by covariance matrix. So this relation between two variables is given by covariance matrix. Say you may have, say, three variables, say like this, then this A, B, C you can write here, then A, B, C. This covariance matrix, I write here sigma 1 or A square, that will give you covariance of variable A itself. When I write here sigma AB, then it is the covariance of variable A with respect to B, and so on. So I can keep on writing like this. This will be AC, this will be sigma BA. So these two are actually same. Okay, so there is a symmetry in this matrix. So BB, and then you have sigma BC, sigma CA, then sigma CB, and sigma square BCC. Okay, so thing is that how to compute all these elements. So there are, if there are three variables, then you have total 9, 3 by 3, that is 9 relations. Okay, so that we want to find out. Now there are two types of covariance, that is positive covariance and negative covariance. And what is positive covariance? If the covariance for any two variables is positive, that means both the variables move in the same direction. Say A is increasing, then B is increasing. If A is decreasing, then B is also decreasing. So they are following the similar behavior, then they are in positive covariance relation. Now opposite will be the case if A is increasing and B is decreasing, and if A is decreasing then B is increasing, then this will be a negative covariance. Okay, broadly we define this covariance in one equation like this. It's an average of outer product of the difference of the given sample with respect to its mean and all such differences added together. So it's an average of such differences, that is outer product of these vectors. Now to how to find out this, that we will see with one example. So the following table, it gives some data. So this is your data. There are three variables. One is student, math, English, art. So this is just student number. So this is not a variable actually. So I should not say this is a variable. This is some data number. Okay, so data number. There are three variables: maths, English, and art. Okay, so for a student number one, this is the data. He got 90% or 90 marks in maths, 60 in English, and art 90. Then second student 90, 90, 30, and so on. Okay, so what we do, we take this data and write like a matrix. So this is my matrix of data. So there are 5 students, so number of rows are 5 and number of columns are 3, because we have extracted 3 features for each student, that is math marks, then English, and arts. Okay, you can call them as features. So these are features of your problem, and the rows are the data points or the objects for which you have extracted this feature. Now, what we want to do is we want to find out a covariance matrix like this. So there will be math here, then English, then art. Okay, and we want a relation with everybody. So this is math, English, and art. So I want this 3 by 3 matrix which tells relation between different variables. Okay, how they are related and what is the spread. So remember, all the diagonal elements here, they will be the variance of that variable itself. Okay, so sigma here will be the covariance of maths. Okay, variance of maths, and the entry here and here, they will be covariance. Okay, so entry here is variance of English, entry here is variance of art, entry here is the covariance of the English and art. Okay, like that we have to find out 9 values. So one way, straight way, is to use this equation. You find out mean vector of all these 5 vectors. Okay, so you can find out mean of these 5 vectors. You add all them and divide by 5, so that will be mean vector. Okay, so then you subtract that mean vector from each this row. Okay, and take this difference row of this difference matrix and do the outer product. Okay, that will be one way. Here I am telling you another simple way of doing this. So we will require 3 steps to do this. Now first step is to calculate this small a matrix, which is equal to a minus 1 1 transpose a into 1 by n. So what is this? This 1 1 is a 5 by 1 column vector, and transpose of that will be, so this 5 by, this will be 1 1 1 1. So this are 5 ones, and then you take 5 ones horizontally. So this is outer product. So that will give you 1 1 1 1 1, then 1 1 1 1 1, like this. So it will be 5 by 5 square matrix. Okay, so this one. So this is 1 into 1 transpose. Now you take this A matrix, this is your data into all ones. So straight meaning is whatever is your data size. So there are 5 rows here. You will take 5 by 5 matrix of all entries once. Okay, so if there are say 10 rows, then you will take 10 by 10 matrix with all entries equal to 1. Okay, then you will do this procedure. You take this data matrix A, then you form this all one matrix, and then you take again your data matrix. So when you multiply this, what will be this portion? This is your A as usual. You will see that I'm dividing here by 5. So if I take this first row and multiply with this first column, so it will be 90 plus 90 plus 60 plus 30. Okay, and divide by 5, right? So this will be the mean of first column. Okay, like this. The entry is now 66. When you multiply this again, this row with the second column, it will give you mean of second column. When you multiply this with third one, it will give you mean. Okay, so remember we are doing this x minus mu, we are computing this. So what happens is, if you repeat this procedure, same thing is repeated. So all these are mu's of your data, they are repeated. Now what happens due to this next step? So A minus mu's, all mu's. So from first row mu is subtracted, from second row mu is subtracted, third row, fourth row, fifth row. From every row corresponding mu is subtracted. So we will get this kind of situation. So from all the data samples, mean of the data is subtracted and you get this deviation matrix. Now what is next step? You multiply this A dash, that is A transpose, with A. Okay, so this A, you will multiply with A transpose. So this will be your A transpose multiplied with A. So this is the transpose version of A, and this is A. When you multiply, you will straightway get a 3 by 3 matrix. Now if I divide this 3 by 3 matrix by number of samples, because ultimately I have to divide this number of samples. When I do A in transpose A, this is computed. Okay, now when I divide by this, it will be covariance matrix. If you understood this procedure, the initial divide by n was doing computation of mu. For this I will require 1 by n here. Okay, that was there, and then I subtracted from every data sample that mean. So it was done within one step, since I am using matrix operations. So this will be done in one step, and then I will divide by capital N, that is total number of samples. Yes, so this will be giving you in one step this quantity. This is nothing but our sigma. Okay, so if you simplify, this is sigma for your data. Now when I say you are being provided data for class 1 and for class 2, suppose there is similar data given to you in table form like this for class 1, and similarly there is data for class 2. Okay, so these two things are given to you, then use this procedure to find out mean for this data, that is mu1, and find out covariance matrix for this data separately. Use same operation and find out mu2 and sigma. Okay, so I am explaining here for only one table. You have to repeat this for if two tables, if there are two classes. You have to repeat this procedure maybe for 3 times if there are 3 classes. Now, if you see closely, and these diagonal elements, if you recall that this was maths, this was English, and this was, I think, arts. This is maths, English, and arts. So when I take variance for maths, it is 504. Variance for English is 360. So take all diagonals. Variance for arts is 720. So you can see there is highest variance for arts. So marks in arts, they are spreaded over quite good range. So we can confirm this by looking into our data. Is you can see that 90 to 30 is the range for arts. Okay. Whereas this is also 30 to 90. But here 30 is repeated 2 times. So there is more weightage to lower side also. And here 30 is repeated only once. Range is same, but weightage here for arts of obtaining 30 is more. So that's why the variance appearing for arts is more. Now, what is the relation between, say, English and, say, maths? Now, relation between maths and English is 360, or English to maths is 360. Since this matrix is diagonal, these two numbers are same. Symmetric, these two numbers are same. You will see that this entry 180 is repeated here. Okay. And 0 is here, 0 is here. So what 0 indicates here is that there is no relation between English and arts. English and arts, 0, there is no relation. Relation between maths and English is 360. And what else? You have maths to English is over maths to arts is 180. Okay, so like this we can see the relation between the variables. The art test has the biggest variance and English test has the smallest variance. So we can say that art test scores are more variable than English test. And what about off diagonal elements here? The covariance between maths and English is positive 360 and covariance between maths and arts is 180. This means the scores tend to co-vary in positive way. As scores on maths go up, scores on art and English also tend to go up, and vice versa. The covariance between English and art, however, is 0. This means there tend to be no predictable relation between the movement of English and art scores. If the covariance between any test had been negative, it would have meant that the test scores on those tests tend to move in opposite direction. That is, student with relatively high scores on first test would tend to have relatively low scores on second test. Okay, so that is what we have said earlier, that if A is increasing and then B is increasing, then they are in positive relation. If A is increasing, B is increasing, they are in negative relation. And if they are not at all related, you will get zero entry. So I hope now you can calculate this sigma matrix which we have used in previous problem. So these sigmas are obtained like this procedure. Then there is one more step here to compute this likelihood probability, the sigma inverse. So sigma inverse is inverse matrix. So you can find out inverse of the matrix. You can say sigma inverse is 1 by determinant of sigma into adjoint matrix. Okay, so you can get this procedure in maths book, or you may be knowing how to find out inverse of this. Now next topic we will see is receiver operating characteristics, or ROC curve. So every classifier employs some kind of threshold value. So changing the threshold affects the performance of system. So ROC curves can help us distinguish between discriminability of these systems and decision bias, that is choice of threshold. So it means that if I take 1D case, this is a likelihood of omega 1, this is say for omega 2, and suppose I say priors are same, then I think base will come here. The base decision threshold will come here, and you can say that this side of the threshold here is class 2, and this side of threshold is class 1. Okay, so base will come in the center of the two curves, so that this portion, if you concentrate, and this portion which is producing error, this portion where samples of omega 1, they are classified as omega 2, and this portion of your threshold, below threshold, is where the samples of omega 2 are classified as omega 1. So this is the error portion. Now if I have set my threshold here, what will happen? Instead of here, suppose I put it here. So major portion of your omega 1 will be classified as omega 2. Okay, so major portion of omega 1 will be classified as omega 2. Now if I set threshold here, then lot of portion of omega 2 is classified as omega 1. So what base is doing, base is setting the threshold such that this error is minimized. Okay, now to see the effect of this threshold, we can have this ROC curves for the classifiers. Now we can see this portion with this X star as threshold continuing with the same discussion. This is called as false positive. Above this line, we have class as positive, and below this line we have class called as negative. Since we have only two classes, I can say positive class and negative class, or omega 2 and omega 1, whichever you prefer, but we will go with this convention, positive and negative. So this is the portion where portion of omega 1 is declared as omega 2. That means false